But recording the session.
Yeah. Well, I do want to say thank you for sharing those cards. I'm going to print those off for class too, so I had those available.
Yeah, this one is actually I had a plan for the Pineville library. They didn't have a time on the earliest time, but they put it the assignment for the I think March 22nd for me for this Saturday. That they accepted is actually sometimes the libraries they don't have any kind of opportunity, but they're gonna print the cards and on 6 sets and ready for the sixth group of the attendees to discuss about this card and instruction. That is good. And also, I know that many of my colleagues in the international different area on Middle East, on the Mexico and Africa, they do the same thing around the globe, and that's kind of new excitement for the specifically teenagers and younger adult to engage on that kind of inspiration and encouragement for the astronomy, and specifically women and girls, and also different indigenous and black and white different races and consideration ethnicity. Anyway, let me go back to the, or if you had any questions, we go back to the presentation.
Well, we're going through some other things and we're throwing it out there. I'm going to interrupt a little bit more. Just realize that a lot of neat things are happening as we've started to do our observations of the planets and then getting into the moons of the objects and such. Planets have a really nice separation across the sky. We're hitting that this month also. It's kind of a unique thing. Everybody talks about planetary alignment. You look at the solar system, there's not really an alignment other than they're becoming equal distance across the sky from Mercury all the way across to Jupiter. And we also have a blood moon eclipse or a lunar eclipse coming up, I believe, here pretty soon on Pi Day.
Yeah,
Um,
I think March 13 or 14, I guess. It's
I
gonna
believe that's
be
right.
observable and from North America, South America, and North America is a perfect sign for the observation. Might be as a good idea either not. I don't trust with this Skynet, but you have to take a measurement yourself, go observe the moon and take some pictures. Probably gonna be exciting moment. Thank you for reminding, John. It was I think March 13 or 14.
Yeah, I know for Farhad being up north of us, that they're talking about, we're at solar maximum right now. I mean, the sun is really going crazy. And the weather conditions may be right for auroras, has been kind of the talk right now. And they may extend quite a ways far south, they're even saying. So, just an FYI, with solar activity, the sun's really been very active, and there might be something going on there also this month.
And also remember that when you're taking the aurora, sometimes if you go further down to the North Pole, you may see it very diligently, but in the lower latitudes, might be visible through the camera. For example, if you have a DSLR camera or cell phone camera, you put it for 20-second or 15-second duration of the picture on the tripod, a small tripod that it exists, or put it in place that doesn't move, and that gonna capture various colors very easily. But I tried. I think the last year on May 10 and the Charlotte area there was observable, but I didn't see anything from my eyes. And I took my camera in 20 seconds, and after I see it, the colorful red and uh, green is very essential on that picture. Therefore, that's dependent on the intensity of the aurora and the other things, but it's gonna be very easy. And also the moon for the for the lunar eclipse, you can easily take a picture with your cell phone or camera. But you have to consider, make sure that its duration is because the moon is bright before the eclipse. You don't need it to wait for 20-second exposure. You can take it in less than a second or so. Same thing that we had in the cheat sheet that I provided, the Excel file, and also the things that we have on the web assign, that it gives you some indication good for the observation. Let me go over to globe for now. For this one is the one that you see it on the Cerro Tololo in the Chile. If we're gonna go um, uh, some other places, for example, this is the Saskatchewan. You see that, and this time at 7 p.m., most of the object. Let me only focus on the solar system, delete the others. You see here, you will see the uh, Neptune, Venus, Uranus, and Jupiter and Mars available. And the moon probably gonna be one thing that remember that if you have looked through a different season, different time of the year, the moon gonna be a little bit far away, and that's a very good sign for taking picture of the planet because they are far away from the moon, and can be pictures gonna be very good. And one other thing that you have to mention, I think we provided some glance on the pictures that you had. For example, let me go to the Skynet here. As I mentioned, when when you go to the optical observation, you do the add a new observation here. You start doing, but when you done the picturing, you will see here some pictures is coming. For example, I look through my pictures that I had before. For example, on the Jupiter, either you click here or ID that you had. When you do that, and here you will identify the object. Most of them, as I mentioned, this one is the main JPG picture that you will see it, like a Jupiter as the scene here. You can make it a little bit zoom in, but the capability of the zooming and out here is not very good. The other option is that you go to the afterglow. When you go to the afterglow, you have to find out your item here. One item, for example, you see Jupiter. If you have few, it's gonna be easy to stake it, but if you don't have it, you click on here. When you click, you don't see it anything here. Then you have to zoom fit to see the object. And also, if you want to see the bright object like a Jupiter or other planets, you click here. Then you see it, Jupiter on the middle. Then zoom it in. When you bring it here, for example, big enough, then you save it. When you click here, download view snapshot, it's gonna show you exactly whatever you see in the picture here. When I click here, you see the Jupiter is big. But if you want to take another option is that take a JPG. When you do that one, it's gonna be a little bit farther distance. You see this one, the second one is not gonna be very kind of close. Therefore, always when you're submitting your assignment on the WebAssign, is better to use this first option, whatever you see it on the picture to download it. Another thing I think I remember, if we look through another items, we're gonna later on the next week, uh, on the items like the moons of the Jupiter, when you wanna see the moons of the Jupiter, it's better to click on the faint target. When you faint a target, you see it here. One of the main items that you identify here, saturation level percentile, is 95%. Therefore, you have to play with this one a little bit, bring it up. As you see it, when I increase it, the saturation level, the noise and the various noise that you see on the picture is reduced. And to reach to the point that is pretty much less noise, close to the 99.6 or 5 or things like that. But when you increase it this one further, you're gonna lose the moons. Then we don't want to do that. If we want to observe the moons also, we're gonna come a little bit farther, little bit noise, but at least we can see it to measure the distances. But that's kind of reminder of the whatever we had on the last week we discussed. And then on the lab 3, we're gonna go over here and take a picture from the moons and do some kind of measurements here. The last thing that I want to reminder about the diameter of the size here. If, for example, the picture that we have it, sometimes when you see it, this one picturing the moons on the right side of the Jupiter might be something like that, or might be something like this. It depended on the telescope that take a picture. Therefore, we can rotate and adjust as needed to make sure that is matched with the stellarium that we see it on the picture. Did we discuss, anyone remember that we discussed about the stellarium, how we can identify stellarium based on the picture that we have and compare it to finding the moons, or not yet? Do you remember anything we discussed on that?
Yeah, I think you showed us that when we look at the sky and from an observer's point of view,
Yeah.
we do see. So, yeah, you just showed us something. And
Okay.
Abbas, before we go there,
Sure.
when I take a picture here, let's say, and I download it, how do I get this one to the web assign to
Oh,
submit the picture?
yeah, yeah. Here, that's a good question. When you take a picture, when here you are on the Skynet,
Yeah.
for example, you take a picture, you see it here. You have to click open Afterglow.
Okay.
You see that below the when you go beginning on the My Observation,
Okay.
you see the add new observation, and you have a list of the completed picture that you're taking.
Okay.
Then you go to the Afterglow, open Afterglow.
Yeah.
You don't see it anything here. When you open here is empty, here is empty,
Mhm.
and you go here, open file
Okay.
on the upper left side. When you click the open the um, file, it gives you three directory. The main directory is file, and there is a three directory. The things that you needed to go to the Skynet Robotic Telescope Network, this folder. Click on that, and there is another three option. The second and third option directory, you see, first directory root is files, second is Skynet Robotic Telescope Network, and then the subfolder here. This group observation collaboration is not related to us at the moment. Only thing that you needed, user observation. It means you as a user, what you observe. When you click here, you see whatever you observe it on the what to call it, on the Skynet, and
Skynet.
then yeah, Skynet. It bring it here, but it's not bring it yet. It is the kind of the same file that taken for you on the Skynet
Mhm.
listed here. To bring it on the right now we are working Afterglow workbench. To bring it Afterglow workbench, you have to identify that. Therefore, to identify that, you don't see it here. When you open it on the when you click here Afterglow, it brings here is empty here. Although you see it something here because I already uploaded. If you don't see it upload, it's gonna be empty here. You click Open Files, you go to the Skynet Telescope Network, user ID, and then here all the picture that you're taking with the Skynet is here. It doesn't mean that it's downloaded, but it means that they are included on the program, and they share it on the data set of the web as workbench and also the Skynet. For example, if you want to check whatever is important for you, for example, Jupiter, let me see if I found the Jupiter here. It's one of them, and or Moon or Saturn here. Let me go something else, like Saturn, for example. When you click here, it gives you here, you see files, Skynet directory, user observation, Saturn. For each object, you're going to have three different images. Raw image has more data, and also this is master calibration image. The only things that important for us is reduced image. You click on the reduced image always. When you click here, it brings you you see, this is Saturn, the observation that I took, and this is the observation ID 11933702, and what filter it taking, B, and this is reduced fits file. Click on that, and when you click it, it takes time, but bring it on the here. But
Okay.
here you don't see it anything. Any question?
No, so far I'm good. I can get to this point, but my question is, if I do need to take it to WebAssign to submit that as part of the homework. Do I need to do that? Number one. And second, if I need to do that, how I can do that?
Yeah. I'm gonna tell you in here that, for example, in here, this is step, you know how to come here. Then here you just put a zoom fit and you see the object.
Yeah.
And if, for example, Saturn, we don't wanna see about the moons at the moment. Lab one is mostly related to the planets on the first assignment. Then you bring it, what to call it, zoom it in larger and larger to see some side. Although you see it very blurry, but that is good enough. Here you just download and save it, whatever you had, and save it on here on the uh, inside your computer and keep it over there. Then you go back to the WebAssign. For example, on here on the lab one, you on the lab one you come here whenever observe the planet. For example, one of them. In here, um, you see this information is a kind of procedure, but you have to go to the. Let me go to the student view to show it to
Yeah.
you
Yeah.
exactly what has been.
Yeah, I've gone through all this and I have a list of the planets. So I wanted to do one planet just as a test
Yeah,
and how I can bring
yeah.
it in
I'm gonna
here.
show you. This is a screen that I have. Uh,
Mhm.
Probably your screen is similar to that. Here
Exactly. Mhm.
you see it on this. You have to come on the lab. You see this one is background, and this one is the procedure. Procedure one is the how to observe Skynet that we already had it. How to check your images, that is good or no. Then the one that is number three, it gives you the again procedure. This all of them procedure A and B, all of them gives you the kind of what you should do and how to do that. After you finish those, you come to the submittal. Submit your answer. For the submit your answer, for example, the first table that you have here, then what you do, for example, you observe the Saturn. You click the file and see where the, uh, for example, Saturn is saved. For example, I click here. And here it says the file cannot be uploaded because of the following reason. This is a kind of, you have to use proper designation name for the file to use it. That is given on the previous procedure. Therefore, but the basic thing is that you needed to provide here if you needed there is some description here on the beginning of the section exists, but assume you just upload it here. The next thing that you need to do, you provide a Skynet observation number. You go back to your Skynet here, see where the Saturn is there. For example, Saturn is here. Oh no, this one is the Saturn before. The one that I take it probably is one of them. You take this one, copy, and bring it back here. Where it was, let me see, lab one. Here, you put, yeah, paste, right? And then you put the image uploaded here and put the Skynet observation here. And you put some observation, some notes here. For example, based on this kind of work that you did it and enlarged the picture of the zone, probably you will see it, you can recognize the ring, you can barely recognize the blurry, but whatever you feel it based on the picture that you're taking, you just put it on here, on the description here. This is kind of insight what you experience and discuss any detail, any particular detail you see it. On the Jupiter, probably you see the layers of the atmosphere. You identify here. It's very clearly you can see the layers, but you don't see a red spot. And for example, a red spot on the Jupiter is not observable on the picture that I took it. Sometimes it is possible, sometimes it's not. Therefore, this is mainly a descriptive thing that it's not graded based on that. For example, if you put one word or two word or two sentence to a statement, what that gonna means, but brings some kind of dialogue between you and the program. That's only intention for that is.
So if I understand it correctly, is that I do observation, I take an image, and I need to save that image in a folder on my computer
That's
and
right.
provide the link to that, or copy and paste the same image that I've
Ye-
taken.
That's right.
Is that right?
Yeah,
Okay.
it's also you choose the file here. When you click on choose here, file here, it
Uh-huh.
gives you, for example, any folder that you have it,
Oh,
and
I
then
see.
when you ident, and it's better to have kind of rename it those in a proper way that you're able to identify those, or if you don't rename it the same name that is the save it, that's good enough. And but you have to go through the procedure section to see what file name is proper to use it on here. And
Yeah.
then after that, you have to put, you need to put the uh, uh, ID here, the one that you see it here. You see this observation, this is ID, this is a name that you're taking, telescope and activities here. Therefore, you only identify the ID here. When you're done here, then you already done and put some word here, and this first task is finished.
I see.
Okay.
Yeah.
What a
Yeah.
boss. Go ahead.
Yeah, go ahead.
Yeah, John, I see your note. Thank you. So what I've done is I've created a folder on my laptop. It's called astronomy, and subfolder that is by planets. So if I take an image of Saturn, I'm going to keep it under that folder, and then I can either upload it or provide a link to that. Okay.
That sounds good. Yeah, what we'll see on our end is that image you post, it'll come right up, and then
Yeah.
we'll have a reference allow us to get into Skynet to see your file if we wanted to do that. And then the notes are really helpful, so we know that you're on track. And if you have any questions, you can put those there also for us.
Yeah, that's exactly what I want, because I do have that and I see it, but I want the instructor and the teacher to see and kind of give me feedback. And as you said, if I have question, I can ask question and get the answers. Okay, I want to make sure that we are looking at the same picture.
Good.
Thank you.
Thank you.
A couple little notes too, we brought before, but like when you're doing Jupiter and you're in the afterglow, or no, any of these when you're doing like Jupiter is what I'm thinking of, but when you're in the afterglow and analyzing it, it's worth looking at it. Take two looks at it. Like the one look would be to do as a bright target, and you get to see Jupiter's image with with the storms across the front, and then go for faint target to pull out the moons. Um, when you look at the bright target where you can actually see Jupiter clearly, take a look on its surface. I know I've seen this before where sometimes you'll see a shadow of a moon over the surface. So you may pick up an extra moon other than the ones that are off to the side by looking at the image that looks like Jupiter. When you go to I'm into it. Let me do it really quick. I'm gonna do it myself. Here, you know what? I'm gonna share real quick and then I'm talking more and I'd rather just show, right? So in this case, I've got it under, there's faint target, which is handy for pulling out the moons. I can see the moons up above. I didn't rotate it yet. But then I also want to go to bright target and look at it itself, and I'm going to zoom in on it just to see if there aren't any of these. I see a few spots that make me wonder, and just to see if there aren't any shadows across, and I can use Stellarium to see if there is another moon maybe I'm missing. I've had that experience myself before.
Thank you, John. And also note that here, the picture that I showed, the orientation was different. The layers was horizontal. The one that you have it, the lines are vertical, and
Yeah.
that is dependent on the telescopes that take a picture. Some telescopes, because of the arrangement of the mirrors and the lenses, in a way that take it that picture, and you have to, you can, if you wanna arrange it, for example, you have to rotate it or kind of do it in a way on the bottom, flip it or rotate it to make sure that is aligned as needed to compare with the Stellarium. later on we're gonna do compare because this one, the picture that we're taking, we don't know the direction. Normally in astronomy, it is not important for us. We just see the circle like a star or galaxy. For us, it's not important which one is the top or which one is the bottom or so on. And the other thing is important for us is that uh, when Skynet take a picture, depending on the type of the telescope, might be in different orientation. Probably we are six of us, we may take a picture, each of us with different telescope, it comes with different orientation. Then later on, we're gonna go and compare it with the Stellarium that I put the link under the email that I sent it. That Stellarium, it's gonna be provide for us a kind of reference app or program, and we compare it or picture with the one that we see it on the Stellarium. That actually, the one that we see it on the Stellarium is exactly correct direction that we can see it with our eyes. And based on that, we can adjust it on the web assign, and then not right now, but on the next sessions that we're gonna go on lab 3, we're gonna go detail on that how we're gonna do. Any questions so far?
Excuse me, I have a question.
Right.
Yeah, I got the Jupiter picture right now, but to see the moon, what should I do? You told me that
Yeah, that's a kind of what you call it. Let me show you here. That's
to see the Jupiter's moon, I mean, yeah.
Yeah, here as you see it here, the Excel file that I provided originally.
Mhm.
This one, as you see it here, this one is when you're taking the first section of the work, task of the work, you choose these filters to get and this exposure to get the planet. We are not concerning about the moon on this task number 3. On the task number 4 for the moons, we have to change. For example, when we're taking the Saturn, we have to, if we want to see the Saturn itself, we needed to use the filter B and exposure 0.3. But when we want to take a filter of the Saturn and the moons, we need to use high true and 0.03. This combination brings what to call it, brings for us the moons on the section. But this one is for the next week or week after uh, task that we're going to do. At the moment, for now, we're just focusing on this this section, procedure 3 only. But later on the lab 3, we're going to go to this moons and also the dwarf planet. You see, this information is slightly going to change.
Okay, thank you.
You're welcome. And then any other things? I think we go back to let me go back to the, what to call it, the web assign that we share it. I'm sharing again. In here, as you see it, this is the first task. You upload the planet and provide ID. And if, for example, if Venus is not observable or Neptune is not observable, you just leave it empty. Don't worry. It's that you don't need it to fill it out all of them, because not every single mount or things, all of them is observable, and you can take a picture or upload it and do all of things. As much as you can do it at this moment, you do it. For example, for Mars and Jupiter and Saturn and Uranus, probably, or might be Saturn is a little bit late also. Probably Uranus and Jupiter and Mars and Ceres, you can do that, but the others, no. The next task is that about taking picture of the angular diameter. I think last week I explained it. For example, in here, uh, the one that we had it, I just briefly go over the way that we're gonna do. We have plotter view here. When we do the plotter and also let me bring this one up. I will see it this way. Okay. Okay, here there is a fourth item here is the plotter, and another one is a marker. The plotter is the one that we're gonna take a measurement angular diameter. What we're gonna do, we just click a few of these options here to identify the, when we clicking by mouse, we can identify the diameter. For example, when I click here by mouse and click here, it shows a kind of various kind of pattern of the light illumination of the uh, planet. And here it gives us the how much angular diameter has. Therefore, we come back here. For each of them, we do the same thing. For example, I will say Venus is observable, yes or no, and what telescope I take a picture. For example, here we have some data here, as I mentioned, I believe last week. The second item on the right is gives you information. For example, here, when I click here, it says what observatory take a picture. Is Perth Observatory in Australia, and the name of the telescope is RCOP. Then I go back here. Name of the telescope, I will say it, for example, this is Saturn RCOP. Here, you see, when we're measuring the, what do you call it, the angular diameter, we always, for the Saturn, we specified here Saturn rings. Therefore, when we do that, we have to come back to the here, the picture that we're taking. And here it shows the from edge of the ring to the other edge of the other side of the ring. Then we measure it and we put it in here. Whatever measure that is yes observable and universal time. This one is all of the times and date that is here is universal time. We can get it from I here. For example, what's the universal time? We have it here. Normally, it's better to take the center time. Is for example, December 10, 2024. Therefore, I go back here. I will say December, not to the units of the uh, information that you have. First, we have to put the month. In the Canada, it might be a little bit different. In the United States, is different. Make sure that you follow the same thing that we had here. And what the date was, I go back here, 10, 10 slash 24. Therefore, we don't put the 4 digit, we put the 2 digits as per the format is given here. And what the time is? Time is here 12, 21, 55. 12. You can record it on your piece of the paper to not go back and forth. Might be is it 12, 21, 55, 25, 55. That's it. Hours, minute, and second. And measure it angular diameter. How much I measured? I go back here. What's measured is 37.548. Copy. Here. Done. The only thing that you have to make sure that minimum you should have 3 significant digits. For example, if you put 37.5 is good enough, or you can put it more significant digits. And then again, you provide your name here. This is kind of way that they provided, a kind of norm that you put your name, you attest that you did it, the observation, just the kind of formality of the uh, course that you had. And therefore, this is kind of activity you can complete it, whatever you measure it, and then when you click submit, it's gonna be submit. Let me see.
Can
Where
I
is this?
ask a
Yes,
side question?
go ahead, go ahead.
Yeah, do you have some tools that converts these angular diameter to kilometer or miles? I mean, how do you know, like in our measurement here, like how much is this angular?
Okay, yeah, that's let me go back to the picture that I showed to you here.
Yeah, I'm
As
trying to get it if there is any way we can make a sense of this angular diameter, this like what does 37 means basically.
Oh yeah, yeah. Your point is that that's the one. Yeah, I'm gonna show you this one. I think on the
Yeah,
previous sessions we just mentioned that normally, briefly speaking, if you consider as kind of perimeter of the circle, how many degrees are? It's about 360 degree, right?
yeah.
Okay, that 360 degree, each degree also divided by, if you consider, let me show you this one. I think it might help. Just give me a second. We go to the second lab that we're going to discuss here. You see this, this is a kind of longitude and latitude on the Earth, on the map of the Earth that you can see it. And the one that we see it on the sky is kind of extension of the whatever coordinate we see it on the Earth toward the infinity, very distant away. Therefore, we're just thinking that this, for example, uh, uh, when you extend the equator on the middle of the Earth, we're gonna see reach the equator on the sky. Therefore, the same equator that we have on the Earth extension become equator on the sky. Here we have 0 degree. When we go upward to the North Pole is 90 north and 90 south. This is a similar to the latitude that we have. We call it declination. Another one is the one that is uh, similar to the meridians or what do you call it, the longitude coordinate system that we have on the Earth. We call it the right axation. The thing is that if we go from this side of the celestial sphere back to the other side, it's 360 degrees. But actually, we don't use it by the degree. We're using based on the 24 hours. Why are we using 24 hours? Because almost close to 24 hours it takes that from the what to call it when one star is on the top of in one location to go back to the same location. It's gonna take about 24 hours. Therefore, it means that during the 24 hours, all the sky gonna rotate around us. This is artificial. This is kind of apparent. It's not real. It's actually we are moving around the sun that we see it that one. But from the old ancient time, they took it that way, that instead of the using 360 degree around the rotation of the sky around the earth, we use 24 hours. Therefore, if it means that every hour is going to be around, if we divided 360 to 24, it's going to gives us around 15 degree. Therefore, each line, this line that is goes from Greenwich is 0, and the next one is the 1 hours after 15 degree, and 30 degree, 40 degree, 45, 60, and so on. And all of them gonna complete the whole circle of the celestial sphere. And then when we go back here, when we say it here, 37.5 arc second, that's the reason is that here, for example, let me show it again. Let me stay here. Yeah, here each degree, how much degree we have for each degree we have 60 minutes, and each minute has 60 seconds. Therefore, this division is comes based on the hours and minutes and seconds. Therefore, whatever you see it here, 37.5 second, it means that it's gonna be around uh, 1 degree divided by 60 is 1 minute, divided by 60 is 30 seconds. Therefore, you have to assign it accordingly on this degree consideration. Let me go quickly. Second. That pictures might gives a better indication on the angle that we had it. I had it. Okay, here. Here, this is a very good view. This is the angle that we see it, angular diameter here. This is based on the arc minutes or arc second is considered. And the division is not based on the degree, minutes, and second. And each 300 3600 second become 1 degree, and 60 second 1 minute, and so on. Therefore, the comparison also comes based on this division that I mentioned on the sky, because every hours we're gonna move around 15 degrees. We just divide it based on the hours. This is kind of very difficult compared to the what to call it we have on the Earth, because on the Earth we have all of them is for example, division between 0 to 360, 0 to 90, or minus 90. But in here on the astronomy, we have similar thing on the declination, but we have a little bit different things based on the hours on the right extension. I hope I didn't overwhelm it and explain it
No, that's
as
good. Thank you.
Okay.
I got it. Yeah.
eh,
Yeah.
eh,
What my question is that, so when we're talking about this angle and we
yeah.
measure that angle, actually, are we showing a distance, a length through that, or what? Like, when we say that so many degrees is the angle, so we want to look at something that falls within that angle. So are we measuring a length? You
No,
know,
no, no. It's only we measuring the angle. This angle.
okay. No, I
Therefore,
mean, yeah, when I see the angle and I move to the right, you have an oval shape there that
yeah,
you show a kind of a distance here from top to bottom.
yeah,
So
yeah.
are we measuring that length by saying this angle
No,
is
no,
showing
no,
it? No,
no, no.
okay, yeah.
At this moment, we're just starting with the measuring this angle. For example, this angle on the one that we see it here is 37.5. But actually, uh, later on, we're gonna measure the size, actual size of this and the distance. On the next labs, we're gonna go that. For now,
Yes.
the only measurement that we're measuring is angle. We don't consider this angle, for example, if another object is, this is a sun that shows here. If there is another object here, for example, next March 13th that we're gonna have lunar eclipse, the sun gonna be, the Earth gonna be between sun and moon. Then this one, whatever we object here, if for example moon is observing moon here closer to the sun, uh, uh, is not closer to the sun, closer to us. For example, moon is here. But because
Okay.
it's smaller, we see it the same angular size. For example, if moon is located here, the angular diameter of the sun and the moon, both of them is about half a degree. Here, for example, Saturn is about uh, 37.5, but the moons here is going to be 50 and half a degree, both of them. But although when we say size of the moon and the size of the sun is same, it doesn't mean that they are at the same distance. It means
Okay.
that we are seeing with the same angle, both of them.
Yeah, Abbas. So is it? So I just want to understand that when I say an angle, is it what is the measure of? So can I say that this is a measure of the relative position to something?
Not relative. It is kind of when we see on the astronomy, this is one of the important things that we have it, because in the old days we don't know the distances. On the beginning, we didn't know how much distance we are. They thinking that all the stars are embedded on the one imaginary celestial sphere about the
Okay, on a
many,
flat surface, let's say.
yeah,
Yeah.
flat surface, whatever. But when, for example, when this one is the kind of way that we're describing, if we want to say, for example, this object, either Saturn or any celestial object, if we want to see this object, one ray that comes from this corner, it's reached to our eye here. Another ray, it comes from here to reach here. Therefore, from farther distance of this object that's seen on the sky, this extreme rays gonna create this angle in our eye. You see, this is assume your eye is located here, and you
Okay,
see
this
this
is the
object.
observer. I'm the
Observe.
observer
This
here.
is, yeah, left on the left side that you see it in here that I showed by my cursor. This is the eye of the observer. You see the eye here,
Yeah.
and this eye see this object this big. Might be he said this big. If a smaller object, the angle gonna be smaller. If the object is greater, angle gonna be wider. Is that correct?
I see.
So
Okay.
You
all
see?
Okay. Yeah. Now I see. It's actually a relative kind of relative size of
Yeah,
something. Okay.
yeah, exactly. That's whatever extension of the big kind of size of the object at two extreme point, it creates this angle in our eyes.
So
Uh,
Abbas,
yeah,
I think if I okay, so I have two angles. This is one alpha, let's call it a beta, and
yeah,
they
okay,
are different like numbers.
yeah.
So what does it tell me if this number is smaller or bigger? So what does it tell me? What do I
We,
understand?
yeah, this one normally, as you see it in this object, this theta delta equal the d small divided by d. If
Okay.
we know this size and divided by this, it gonna gives us this angle
Okay.
based on the geometry.
Yeah.
Then, if this angle is, for example, one of them is 1 degree, one of them is 2 degree, but the objects are the same distance, but angles are one of them is smaller than the other one. It means that because the distance is the same, one of them is smaller than the other one. If they
I
are at the same distance,
I see. So yeah,
yeah.
that was actually what I mentioned as a relative size or distance.
And
Okay.
also, on the other hand, if you assume this is a sun, our moon is the same angular diameter, almost the same as the sun. If our moon is located here, therefore the angular diameter of both of them are the same.
Mhm.
We saying the same size. Moon and the sun is almost the same, but
Right.
they are not at the same distance.
Okay.
Therefore, the moon is going to be closer to us to see it. For example, if I scratch it somewhere here, at the same circle here, it's going to be more closer. And if it is, you have, for example, one small kind of sphere in your hand, you put it between you and your moon,
Mhm.
you will see it the same size of the moon on the same distance. Therefore, this is kind of relative, as you mentioned, that's correct. It gives us the actual size plus the distance. If we know the actual size and divide it by distance, we're gonna get this angle.
I see.
Therefore,
Okay, but we
yeah,
start with not measuring the distances. We
no, no,
start
no.
with
We
measuring the
measuring
angle
the angle. Yeah, yeah.
and then
For now,
translate it to distances.
yeah.
Okay, that's
Later
what
on,
I want.
For example, if we know this angle and we know the distance, we can get how much the sizes is. For example, if we know the angle of the sun, and we know that from sun to earth is about 150 million kilometer or miles, whatever miles is that, we can get the actual size of the uh, sun. And same thing for the moon. We can do that. And if we don't know the distance, we know the sizes, we can get the distance based on that. Therefore, this angle gonna help us to figure it out three things: one angle, one distance, one the size of the object.
Okay, got it. Thank you so much,
You're welcome.
both
You're welcome.
Abbas and John as well. So because I'm reading what the John notes that is here, so it really helped me. Thank you.
Okay.
Yeah.
Then when you're putting this information here, you just submit the answer. When you submit the answer, that's gonna record in your booklet. For example, your answer, oh, there is some issue here. I have to check it my data, make sure that I put it the right response. That's a good thing. Sometimes we made a mistake on the spelling or something. It gives information that is not correct. You have to do it. But this is basically you should do for the submittal for each observation you doing. Any question? Okay. The next thing on the you're gonna have more items here. I will just not go all of them, but quickly show that for each item that you let me see where we was here. Yeah. After this, for example, you go to the Stellarium that I explained it. On Stellarium also, we're gonna provide we're gonna measure. For example, here we measure the 37.54. And for example, we go to the Stellarium and measure the dimension here, for example, 39, something like that. When we're putting this one, it should we put some percentage error, and the percentage error is like this one, your measured value, professionally best determined value, that is this value that is given on the Stellarium, and you can get the actual what the percentage error gonna be. And then you just describe what you needed this error might cause. Normally, we don't provide a human error because whatever error we see it here is not a human error because we just might be related to equipment, might be something else that identify those accordingly. And how are we gonna do that? In here, for example, as I mentioned for the, let me see, the Saturn. I said we go we just identify this time. Let me go to the Stellarium. I said this Stellarium is the one that gives us the, what to call it, the basic data for the measurement and power tool. I go, for example, web, Stellarium web, and then I recommend to use the app, download it, it's free. You can have it very easily. I delete those and then I check the, I think, time. Time, you can change it the time. Whatever time we had here, 10th of the December 2024. I change it, no, 12, 10. This is the time that I have. What time I had was this one? Is Greenwich time, 12:21, 6:55. Therefore, I have to check to make sure that the time that we had it here is Greenwich, because normally when you uploaded this one, it's going to be based on the data that you have it in your set. Let me check here. Setting.
I think the location, the bottom left says near Forest
Bottom
River.
left here.
Where it says near Forest River Drive. You're trying to change location, are you?
Here.
Keep going, other left. So not the right, but the left side. Hit that tab right there. That's the one you want.
Oh, yeah. Here,
Okay.
UTC. No. Oh, GMT. Oh.
I try to remember, is it Greenwich you put in for that one?
Yeah. Let us see. Cambridge.
Yeah.
You know, Greenwich, you have in the United States also. We have to make sure that we took it the right. Uh, Greenwich
They don't
observation.
do Texas. I
Yeah,
think
this.
the one in England will do, the Meridian Courtyard. That would actually be the
Yeah,
same.
this one. Yeah,
Yeah.
this one is you suit the Greenwich, England. Okay, use this location. Okay, here probably is right when we're choosing the date. Therefore, 10th of the December, and what time was is about 12, 21, 55. 12, 25, 25, 55, 51.
It's 1221. Sorry, 1221.55.
21. Yeah, thank you. This second is not very important, but as long as you make it very accurately, is good. Then, because when you do it, it's gonna change. It's not gonna stay. Then you go Saturn. Check the Saturn where it's located. Yeah, planet. And then here you bring it closer. Okay. Okay, then you compare it with the one that you had it here, but here, let me go to see
Yeah.
the picture is on this side. Let me see if this, yeah.
One nice thing of doing the search and putting your object in the search, it will center on it. Otherwise, it's going to drift across your screen. Once you put it
Yeah.
in the search, it no longer drifts.
What I should do? Yeah, that's, I think is fix it right now.
Yeah, you're doing good.
Yeah,
Good
yeah.
search.
Therefore, right now you compare it this one, and when you click on the, what to call it, the um, Saturn itself, I think it gives you some information on here. Let me see. So I get to use the app, not the web.
To point out there, you can really see Ria's way out to the left. And that's one thing about these images. Some of these moons are quite a bit of ways from the planets when you image them. So, as far as stars and moons, it's worth taking a second look that there might be more moons than you know.
Do you remember, John, how we can get the information about the more information about this on the web, or we have to do it from app on the computer?
Yeah, I think we run into Stellarium. I wish that the web and the downloaded program are the same, and
Yeah,
they're not.
let
A
me
lot of
go to the
differences.
app. Yeah, because I think that has more limitation.
Yes.
When you use the, do you see my screen right now? Are you opening the app on the
No, you
desktop?
still got the web browser still up. You may have to go back out and go back in.
Yeah, yeah.
The
Let me
web
do it.
version only takes you to Wikipedia, I think, and then the installed version should give you a lot more information built in.
That's yeah. That's one of the key things that you always have to remember. That's better always to do that observation here. We just go. I have to see. Let me see. Okay, here. Then it's better to delete those objects. And then only things that is important here, you just have to come here and identify the location. And here, when you come to the app, on the left side, you bring your cursor on the left side. The top icon here, you have to identify the location. Then here you provide Green, Greenwich or Greenwich.
Yeah, you're doing good. Yeah, they're so different. It's just amazing. And this one will overtake your whole screen when you open it up. The other one can just exist as a browser.
And or you just choose it from here. For example, I think this one is better. When you go UTC, GMT and UTC, both of them same. Therefore, you take CG UTC 0 here. When you check this one, then it's gonna be based on the this list that you identify your object. Then you come the time. Again, for the time, uh, 12, 10, and then
12, 20,
huh?
12, 21, 55.
No, 12, oh, 12, 15, yeah, thank you. And then let me see, date and time. Uh, 21. 21, right? 55. That second is not important. Therefore, the date and time is specified here. Then we go find the object. For the finding the object, use here. First one is the location. Second for the day and time. And the search window, you have to take Saturn, for example. Saturn here. Then bring the Saturn on the Saturn. Then you close it, this one.
It's worth noting that for these objects, for Saturn and Jupiter, getting the minute right is actually important because these moons move fast. And 30 minutes, an hour will make a difference in their position.
You see, this orientation is not the same orientation we take a picture. But the only thing that we needed from here is angular diameter. As you see it here, you have to find the angular diameter, whatever is given here. Apparent diameter. This is how much it is. This is a without ring. This is with ring. With ring is 39.98. How much we get? You remember? 37 something, right? This is a kind of measurement that is given on this time on the sky. The Saturn is 39.98. Then we keep it this one. Everybody catch it how we get this one? You had any question on the Stellarium here?
Excuse
Any
me,
question?
it said apparent diameter.
Yeah. Apparent diameter. Apparent diameter means the what to call it. This is actually the same as the angular size
Oh,
because all of them is although apparent diameter here is given what to call it based on the degrees and second, minute, and degree. Therefore, although they say apparent diameter, that apparent diameter means actually the angular diameter. They call it different terms. But you have other things also. You can identify, you see this one planet, magnitude. We're going to go over this gradually, but we don't need it to memorize all of them. But one of the important items that he had, we can get the size here as well. And this one, kind of, let me see, I show you here. Elongation, illuminated distance. Oh, distance. This is distance from sun, and this is distance that he gave us about location and the other things, apart side of that, and I think okay. This one, the one that we had it here, the one that is important for us at the moment for this activity is only apparent diameter. It means that same angular diameter, although here they call it apparent, but it actually means same thing. We just record here 39.98. Then we go back here, you close, and you back again. It's,
Boss, but when you
yes.
get done, I'm going to share real quick too. I'm going to watch our time. We're a little bit after 8, so.
Oh, yeah. Okay. Thank you reminding. But this is kind of last thing that we're gonna mention here is the one that is we provided in this section, and we just go to the lab and submittal, and whatever we measured is 39.98. Whatever we measured by our picture is 37 point something. This is one of the measures that we taken from our picture, and they are very close to each other. But there is some percentage error we had that we put it here. That's going to be complete this task. I think this is the one that I want to emphasize only. That takes a little bit more than 1 hour. Sorry about everyone, but hopefully you get the point. But a little bit might be on the beginning is very difficult. But if you get to used to it, to open, I recommend to you always use the app, download the Stellarium app on your computer. The one that you can do it based on either you have app or Windows or other devices, you can do it. Any question?
I'm going to share something real quick, if that's okay.
Sure.
So going through this. This is a little bit off topic, but one thing I noticed was if you go into Skynet, the telescope sites, if you know you've got an observation going in, as soon as it gets dark in those regions where your telescope is, these are live, which is really fun. I was able to actually watch one of my observations happen last week because I knew the object and it shows that it's actually taking the observation. And then when it was done, it came on my account. So I knew I just had seen them take my observation. Um, in Afterglow, I want to point a couple things here. Like here is my Saturn here. Um, if I'm using the plotter tool and I drag across Saturn here, and I get the nice little shape here to the right. Um, I'm going to do that again real quick here, though. I'm going to go and if you wait to put the second click, you can scroll across here to kind of see the shape and find where your best cross section is. And I like to go a little bit early, a little bit far, so that I can see where it's starting, where it ends, and I can kind of estimate where this will terminate at on the left and right side. If you bring your crosshair down to that horizontal line at 0, it will tell you where it thinks it is location-wise, and it'll do that actually on both sides. If you want to play around with how wide it looks to you, you can subtract those numbers and figure out the width that way. And that'll correspond. Now, my length here is wrong because it's much too wide, but I can use this to kind of make another estimation of width of objects. Other thing worth pointing out here, I had brought up, let me get across, I think I might have shared this last time, but like Venus, there it is. When I do this, I am pegging out. These peg out around a little less than 70,000. And if I compare that to my image of Jupiter here, when I come across it, it's around 3,000, but it gives us an idea of how much range you have for brightness. Um, and so as we're learning exposure rates, I've been running a lot of different exposure rates on some of these planets because it doesn't cost much to do it. And I've been just kind of curious to see um, what the best exposure will be. The brighter it is, the more contrast you're going to have in your image and more details might pop out. If you go too high like the Venus image, then you lose everything because it washes out. Just a little thing we're going to learn as we try the different filters. You can look at how good your image is by using this plotter tool to see how bright it really is. If I compare a couple of my different Jupiters, this one pegs at about 3,000. And I think this one pegs out around 5,000. So there's a little more information in this picture, which is kind of nice. And it does look really pretty anyways. So just a couple things I wanted to share. And I don't know if there's any questions on that or that. Thanks, boss. Awesome. I think tonight going through all this material. Any questions
Thank
anybody have?
you. Thank you, John. That's a good point that I already identified. I want to add another thing on the graph that you see on the right side, as John mentioned, the various things as you take the line on different things. This is kind of things that it is discovered, I think, more actively on the astronomy from late 1980s and 1990s. And before that, there was no such things that we can measure the light and photometry precisely like that. And based on that, we can not only get the because whatever we have on the sky in astronomy is far away light sources. And if we can measure the light sources variation, we can get too many things out of it. For example, exoplanet right now, they observing by the uh, changes on the light curve of the two component that is one star and one planet that is rotating on it. Or if there is two stars beside each other rotating around each other, the curves is going to change and deepen out, or as John mentioned on the graph. This kind of things is very useful on the astronomy, and it gives us, although we see it light and we see the graph, but whatever we measure it based on the graph gives us tons of the information about the sizes, about the rotation, about the other features of the physical features of the object, including chemical, if we go to the spectroscopy. But long story short, this kind of evaluation of the graph that you see it on the Skynet and the Workbench is a kind of very powerful tools for all of us as a citizen science or astronomy lover or professional astronomer to get exciting experience and scientific work. Any question?
Well, thank everybody for tonight. It's a lot of fun. Always learn something every time, and the interaction's really nice.
Thank you
Yeah.
so much for
Thank
your
you.
patience with my questions. You know,
You asked the right question. We needed to hear that one, so that was really good.
oh,
Thank you. Thank you,
Thank you.
everyone. Have a
Bye.
Thank
great
you.
evening. Bye-bye.
You too.
Yeah.
Bye-bye.